Okay, so welcome everyone to the session, and this is our fourth session. This is my fourth session on YouTube, and this session is going to be on the trigonometric values of certain angles. Okay, so I hope that you are already aware about that. We have a table. Let me show you the table if I have. You have a table just like this, where we have the sine, cos and tan values of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, right? So in this session, what we will learn is how do we got this properly this values of this trigonometric ratios. Okay, that is, how do I got that my sine of 0 degree is 0, or how do I got that my cos of 60 degree is 1 by or half itself. Okay, so we will learn that how do I got all these values. Okay, so then before going for the session, so let me introduce myself. So I'm Sagar Bansod, and this Sagar01, which you can see here. Okay, this here, that is my referral code. Sorry. Okay, and I'm from Nagpur, Maharashtra, and currently I'm studying at IIT Bombay in the chemical engineering department in the third year. Okay, and then I have taken my JEE Mains and advanced coaching from IIT Mumbai in the batch of 2017-18. Okay, and the link which you can see here in the red color, okay, this link. So let me, okay, I cannot highlight, fine. So this link which you can see here, so that is the link for my Unacademy profile. Okay, so if any one of you want to watch my video on Unacademy, then you can just visit to my profile and you can watch all my videos there. Okay, then again, if you want to ask me any doubt personally, then you can use this link which is in yellow color. Okay, this link, this one. So you can use this yellow color link to join the Telegram group. Okay, and you can ask me any doubt there, or if you have any question which you are not able to solve anything, you can just write in the group and then I will answer you there. Okay, and one more thing, that recently I have started a new plus course on Unacademy. So I guess it's from 15th of January I have started the course, and today I had the fourth session for that course. Okay, and then that course will last till 30th of January. Okay, and that course is going is a comprehensive course on triangles and circle. Okay, so if any one of you are struggling with this two chapter, that is either triangles or circle, then you can just watch my plus course, and you can feel free to reach out to me for any questions regarding these two chapters. Okay, so let me move forward. So again, to watch the plus course, you will need to subscribe the Unacademy. Okay, so the links which are given here in the brown color, so they are the links for subscription. So if you are a class 9 student, then you can use the first link for subscription. Okay, and if you are a class 10 student, then you can use this second link for the subscription. Okay, so most of the students watching this session will be from class 9, but if any one of you or any of your friend is from class 10, and if he or she wants to subscribe Unacademy, then you can provide with this link, and then he or she can subscribe for the Unacademy. Okay, and these are the benefits of the subscription of Unacademy. So they are the daily live classes, then the live tests and quizzes, then a properly structured course. Okay, and then the unlimited access to all the things of Unacademy. Okay, once you subscribe, the entire Unacademy is yours. Fine. Okay, and again, for the subscription, you can use my referral code, which is this Sagar01, capital SAGAR01. So if you are using my referral code, then you will get a discount of 10%. Okay, so you can see that what's happening, man? Okay, you can see that the actual price for this subscription is rupees for the 6 months is rupees 9,000, right? But if you are using my referral code here, so you will need to you will need to enter my referral code here in this box. Okay, so if you are entering, then you will get a discount of 10%. That means a discount of rupees 900. Okay, for the 6 months. So you will need to pay an amount of rupees 8,100 rupees. Fine. Yeah, so this is the benefit of using a referral code. Okay. Yeah, and again, if you still haven't subscribed our channel, then do subscribe it as soon as possible, and then like the videos and also share them. Okay. Okay, now let us start with our today's topic, that is the trigonometric values of certain angles. Okay, so before that, let me see if any one of you have any questions. So okay, let me just refresh the page. Okay, so no questions, then let me begin with the session. So first of all, let me give you the introduction about the trigonometry. Okay, so in this triangle which you can see here, okay, let me first of all erase what I have drawn here. Okay, yeah, so in this triangle A B C, okay, let us suppose this as my angle theta. Okay, and here while taking this session, I am presuming that you are already aware about all the concepts in trigonometry. Okay, so that's why I will directly start the okay, first of all I will give you just a very little bit introduction. Okay, and then I will directly start with the values of this trigonometric ratios. Okay, yeah, so then let me start. So in this triangle, let us suppose that this is my angle theta. Okay, then if I want to find out the sine ratio of this angle C or angle theta, then that will be opposite upon hypotenuse. Okay, so what is the opposite side to my angle? So my AB is the opposite side to my this angle, so therefore my sine C or sine theta will be opposite upon hypotenuse. Okay, that is AB upon AC. Similarly for the cos theta, so my cos theta is given by adjacent side to my angle upon hypotenuse, so my BC is the adjacent side. Okay, and AC is the hypotenuse, therefore my cos C will be BC upon AC. Okay, and similarly for the tan theta, my tan theta is given by opposite side to my adjacent upon the opposite side to my angle upon the adjacent side to my angle, therefore my tan C is given by opposite side which is AB upon the adjacent side which is BC. Okay, hello Samiksha, welcome to the session. Yeah, and this is how my sine, cos and tan ratios are defined. Okay, so sine is defined as the opposite side upon hypotenuse side. Then cos ratio is defined by the adjacent side upon the hypotenuse side. Then the tan ratio is defined by opposite side upon adjacent side. Okay, so these are the definitions of my sine, cos and tan ratios. Okay, now this is for the more information that you know that your cosec theta is the reciprocal of sine theta, then your sec theta is the reciprocal of cos theta. Okay, and your cot theta is reciprocal of your tan theta. Okay, yeah, and also you should remember these properties, that is your sec theta is also equals to cosec of 90 minus theta. Okay, and here I am giving all this information just as an extra information. Okay, because this is not my proper topic for today, so this is for the introduction right now, and within a minute or two we'll start with our today's topic. Okay, yeah, so our cosec theta, like my cosec theta is also equals to sec of 90 minus theta. Then my tan theta is also equals to cot of 90 minus theta, and cot theta is also equals to tan of 90 minus theta. Then again sine theta is equals to cos of 90 minus theta, and cos theta is equals to sine of 90 minus theta. Okay, yeah, now these are the trigonometric ratios for some particular angles. Okay, so let us suppose that you have a triangle like this. Okay, now okay, I cannot draw proper straight line, but still assume that this is a right angle triangle. So this is your A, that's your B, and that's your C. Okay, so if this is my angle C, and suppose that if this is 30 degree, so if this is 30 degree, and if I ask you to find the sine of this angle, okay, then you can just directly remember this this sine, cos, and tan ratios. Okay, so for this angle C, you can just directly tell me that your sine C will be equals to half. Okay, your cos C will be equals to root 3 by 2, and your tan C will be equals to 1 by root 3. Okay, that is my, okay, where should I write? Okay, let me write here. So my sine C, which is AB upon AC, that will be equals to half. Okay, my cos C, which is BC upon AC, so that will be equals to root 3 by 2. Okay, and my tan C, which will be my AB upon BC, right? So that will be equals to 1 upon root 3. Okay, these are the things which you can directly tell me if you know that one of your angle is 30 degree. Okay, similarly, since this will be your 60 degree angle, right? Therefore, you can also tell me the sine, cos, or tan ratios for this angle. Okay, so your sine ratio for this angle will be under root 3 by 2. Okay, then the cos ratio for this angle will be half. Okay, and the tan ratio for this angle will be under root 3. Fine. So what I want to tell you is just that if you know the angle of your theta, then you can just directly tell me what is the sine ratio or cos ratio or tan ratio of that angle. Okay, so in this session, what we are going to find out is how do we got these values of the ratios. Okay, so for that, first of all, let us start with the 30 degree. Okay, that is the, if your angle of any triangle is 30 degree. Okay, then how I will say that my sine or cos or tan ratio, what is my sine or cos or tan ratio for a 30 degree angle. Okay, now, okay, then let us start with the proof. So first of all, here we need some of the information before that, the information of 30 degree, 60 degree, 90 degree triangle theorem. Okay, so we need an extra information of 30, 60, 90 triangle theorem, and that theorem says that, let us suppose I have any triangle ABC, okay, where any of my angle, acute angle is 30 degree, then my another acute angle is 60 degree, and the rest of the angle is 90 degree. Okay, let me again repeat. So that I have a triangle ABC, okay, where my angle B is 90 degree, then one of my angle is 30 degree, and the another angle is 60 degree. So my theorem says that the side which is opposite to my 30 degree, okay, that is side which is opposite to 30 degree, that is AB, is half of the hypotenuse. Okay, so this side AB which is opposite to my 30 degree, okay, this is half of my hypotenuse. Okay, this is a theorem which is given as 30, 60, 90 triangle theorem. Okay, and again it have one more sentence that the side which is opposite to 60 degree, that is this side BC, is equals to under root 3 by 2 times of hypotenuse, which is AC. Okay, you can also see the statement here, that is, we know that if the measure of angles of a triangle are 30, 60, 90, so you can see this is your 30, this is your 60, and this is your 90. Okay, then side opposite to 30 degree angle is half of the hypotenuse. So this side which is opposite to 30 degree is half of the hypotenuse. Okay, and side opposite to 60 degree angle is under root 3 by 2 times of hypotenuse. Okay, so the side, this side, okay, side BC, which is opposite to my 60 degree, so that is under root 3 by 2 times of my hypotenuse or my side AC. Okay, okay, let me refresh the page because there is some problem from my side. If you have any questions or something, okay, you don't have any question, fine. Fine. So first of all, we should know these two things. That is, my AB is half of AC and my BC is equals to under root 3 by 2 times of AC. Okay. And also I have written these two statements here. That is, my AB is equals to half of AC and BC is equal to under root 3 by 2 times of AC. Okay. So using these two theorems, okay. So using these two theorems, we will try to find out all the sides of my triangle PQR here. Okay. Okay. Hello Madhu. Welcome to the session. And yeah, guys. So if you are having any question in between the session, you can write in the live chat. Okay. Yeah. Okay. Now let me continue. So in the previous question, in the previous slide, I had that the side opposite to my 30 degree. Okay. So this side. Okay, what happened? Yeah, so my PQ will be equals to half. Shit. Yeah, sorry. Will be equals to half of the hypotenuse, that is PR. Okay, and the side opposite to 60 degree, that is this side, QR, will be equals to under root 3 by 2 times of my hypotenuse, that is PR. Okay, so now if I give you that, if I'm giving you some information regarding the triangle, that is your triangle in triangle PQR. Okay, in this triangle PQR, this angle is 30 degree, then this is 60 degree and this is 90 degree. Okay, and just suppose that your this length of this side PQ is length a centimeter. Okay, then using this two equations, we can find out the length of PR as well as PQ, or sorry, QR. Right. So first of all, we will use this equation and we will try to find out the length of PR. Okay. So we know that my PQ is equals to half of PR. Okay. So PQ is equals to half of PR. So, and it is given that my PQ is equals to A. So my PQ is equals to A. Okay. And okay, now what I will do, I will take this 2 to the right hand side, to the left hand side, and my PR will be equals to 2A. Right? My PR is equals to 2A. Therefore, this PR is written as 2A here. Okay. And then now to find out the length of QR, so now I will use this equation, which says that my QR is equals to under root 3 by 2 times of PR. Right. So my QR is equals to under root 3 by 2 times of PR. So what is my PR? My PR is equals to 2A. Okay. So that is equals to 2A. So this 2 will get cancelled out and I will have my QR as under root 3 times A. Okay. Therefore, this QR is written as under root 3 times A. Fine. So therefore, finally, I found out that if PQ is equals to A, then PR will be equals to 2A, or the hypotenuse will be equals to 2A. Okay. And QR will be equals to under root 3 times A. Okay. That is, this adjacent side of 30 degree will be equals to under root 3 times A. Okay. Let me see if someone is having any questions. Okay, no one. Yeah. Okay, therefore you have found out the lengths of PR and QR. Okay, now let us suppose, okay, let me show you the next slide. Okay, let me draw the here itself. So now let us suppose that if I ask you to find out the sine, cos or tan ratio for 30 degree or 60 degree. Okay, so you can, I hope that you will be able to find it out. So let me first of all erase all the things here. Okay, and then we will try to find out the sine, cos and tan ratio for 30 degree or 60 degree. Okay. Just give me a minute to erase all these things so that my sheet will be clear. Yeah, so now they are cleared. Okay. Now if I ask you to find the sine of 30-degree angle. Okay, so since you know that this is your 30-degree angle, okay, that's your 30-degree angle. So, and you also know that this sine is given by opposite side upon hypotenuse side. Okay, so what is your opposite side? It's PQ. So your sine 30 will be equals to PQ upon PR. So PR, and you know that the length of your PQ is A. Okay, so the length of PQ is A, and the length of PR is given as 2A. So this A will get cancelled out and you will be left with a half. Right? So what you got is your value of sine 30 degree is half. Okay. Now if I show you the next slide, you can see that your sine 30 degree is PQ by PR is A upon 2A, and that is equals to half. Right? This A got cancelled out. Okay. Now similarly, in the previous slide, if I ask you to find out the value of sine 60 degree. Okay, so now you know that this angle is your 60 degree angle. Okay, and if I ask you to find the value of sine of 60 degree, so sine 60 degree will be opposite side upon the hypotenuse. Okay, so your opposite side is QR and the hypotenuse side is PR. Okay, so your QR or the length of QR is given as under root 3A, and your length of PR is given as 2A. Right? So this A will get cancelled out and you will be left with under root 3 by 2. Okay, therefore the sine 60 degree is given as under root 3 by 2. Now if you will have a look over the next slide, so your sine 60 degree was QR by PR, so your QR is under root 3A, okay, and your PR is 2A. Therefore finally your sine 60 degree is given as under root 3 by 2. Okay, now again let us suppose if I ask you to find out the value of cos 30 degree. So if I ask you to find out the value of cos of 30 degree, okay, so now you know that the cos of 30 degree is given by the adjacent upon hypotenuse. Right, so this is your 30 degree angle and QR is the side adjacent to your 30 degree. Right, so your cos 30 degree will be QR upon the hypotenuse, which is PR. Okay, which is PR. So your QR is under root 3A, okay, and your PR is 2A. Therefore this A will get cancelled out and your cos 30 degree will be equals to under root 3 by 2. Okay, similarly if I will ask you to find the value of cos of 60 degree, cos of 60 degree, then this is your 60 degree angle and this PQ is the length which is adjacent to your 60 degree. Okay, so your cos 60 degree will be equals to PQ upon PR. Right, so your PQ is A and your PR or the length of PR is 2A. Okay, so it's 2A. Therefore this A will get cancelled out and the cos 60 degree will be half now. Fine, so that's why again let me show you the next slide. So you found out that your cos 30 degree is under root 3 by 2, okay, and your cos 60 degree is half. Okay, just like here. So the cos 30 degree is under root 3 by 2 and cos 60 degree is equals to half. Okay, now I have these four ratios, that is sin 30, cos 30, then sin 60 and cos 60. So now I hope that you are already aware that your tan theta is given by sin theta upon cos theta. Okay, I hope that you are already aware, but if you are not aware, then you can just take a note of this thing, or you can write in your notebooks that your tan theta is also equals to sin theta by cos theta. So since you have the value of sin 30 degree and cos 30 degree, you can find out the value of tan 30 degree, right? So therefore your tan of 30 degree will be equals to sin of 30 degree upon cos of 30 degree. Okay, so now what is your sin 30 degree? It's half, right? So that is half. And what is your cos of 30 degree? So it's under root 3 by 2. Okay, so this 2 will get cancelled out, and at the end you will be left with 1 upon root 3. So in this way you have got the value of tan 30 degree, that is 1 upon root 3. Okay, you can see here also that your tan 30 degree is 1 upon root 3. Similarly, you can find out the value of tan 60 degree using the sine and cos values of 60 degree. So let me write here. So your tan of 60 degree will be equals to sine of 60 degree upon cos of 60 degree, right? So your sine 60 degree is under root 3 by 2. Okay, so under root 3 by 2 upon your cos 60 degree is half, that is 1 by 2. Okay, so this 2 will get cancelled out and you will be left with just a root 3. That's why your value of tan 60 degree is given by under root 3. Okay, so your tan 60 degree is given by under root 3. Okay, so here I have told you using the formula of sin theta upon cos theta, but you can use a general formula also, that is the tan theta is given by opposite upon adjacent, right? So you can use, or you can find out the tan 30 degree using this formula, so that is opposite upon adjacent. So your PQ upon QR, so you know that your length of PQ is A and length of QR is root 3A, so this A will get cancelled out and you will be left with a 1 by root 3. Similarly for tan 60 degree. Okay, so in this way we have found out the sine, cos or tan ratios for 30 degree and 60 degree. Okay, so now in the table, so in this table we have found out the sine of 30 degree, then cos of 30 degree, then tan of 30 degree, and also the sine of 60, cos of 60 and the tan of 60 degree. Okay, you can recheck and verify whether the values given here in the table, okay, and the values we obtained here in this slide and in this slide are same or not. Okay, and you will end at the end you will see that they are same. Okay, yeah, so in this way we have found out the values for 30 degree and 60 degree. And yeah, you can also check from here that your sine theta is equals to cos of 90 minus theta, right? So if I tell you that your theta is equals to 30 degree, okay, then you can say that your sine 30 degree will be equals to cos of 90 minus 30, that means 60 degree. Okay, so if you will check that your sine 30 degree, which is half, okay, and which is equals to your cos 60 degree. So what is your cos 60? It's also half. Okay, so your sine 30 is equals to cos 60. Similarly, you can also check for if your theta is equals to 60 degree. Okay, so your sine of 60 degree will be equals to your cos of 90 minus 60, that means 30 degree, right? So your sine of 60 degree, your sine of 60 degree is under root 3 by 2, okay, and your cos of 30 degree, so this is your cos of 30 degree, which is again under root 3 by 2. So both the things are again same. Okay, so in this way you can also verify your these properties or these equations, whatever you say. Fine. Okay, now let me move to the next angle, that is 45 degree. Okay, and before that, let me check if someone is having any question. Okay, hello Tejas, welcome to the session. And okay, so no one is having any question. Then let me begin. Let me continue. Yeah, so for the trigonometric ratios of 45 degree angle. Okay. Okay, now let us suppose that you have any triangle just like this, A, B, C. Okay, where your angle B is 90 degree. Okay, and this angle A and angle C are 45 degrees. Okay, then I hope you are already aware that in your chapter triangles, you have a theorem of 45 degree angle triangle theorem. Okay, which says that your BC and AC. So let me write your BC and AC are 1 by root 2 times of your, sorry, not BC and AC, your BC and AB. Your BC and AB are 1 by root 2 times of your hypotenuse, that is AC. This is what my 45 90 theorem says. Okay, but don't worry, I will also give you the proof for this theorem here itself. So just leave this thing for now. Okay, and now pay attention to the this proof. Okay, so I hope that you are aware about the isosceles triangle theorem. Okay, so isosceles triangle says that if in any of the triangle the two angles are same, okay, if the two angles are same, then the lines or the sides which are opposite to these two angles will also be same. Okay, so since I have my angle A and angle C as same, okay, so this BC is opposite side to my angle A and this AB is opposite side to my angle C. So since this angle A and angle C are same, therefore my AB will also be equals to my BC. Right? You should know first of all this thing. Okay. Then again, using the right angle theorem or the Pythagoras theorem, you will say that your AB plus AB square plus BC square is equals to AC square. Right? Your AB square plus BC square will be equals to your AC square. Okay. So now for the calculation, just assume that this is your A. Okay, that is AB is given as a centimeter. Okay, therefore your BC will also be equals to a centimeter. Right? Okay, what's happening? So hello everyone. Okay, hello everyone. Yeah. Okay, then let me continue. So we are just assuming that my AB is equals to a centimeter. That's why my BC will be also be equals to a. Okay. So therefore my AB square plus BC square. So I can write this equation using the Pythagoras theorem, and therefore my AB is a. So that will be a square. Then this BC is also a. That will be again a square. Okay, and that will be equals to AC square. So this a square finally it will become 2a square, that will be equals to AC square. And if I take a root on both the sides, so now that will become under root 2a is equals to AC. Fine. So I got the length of AC, that is the length of the hypotenuse, which is now under root 2 times of A. Okay. So now what I have till now is that the length of the two sides are A and the length of my hypotenuse is under root 2 times of A. Okay. So now using these three lengths, I can find the sine, cos and tan ratios for the 45 degree angle. Okay. So now for going further, let me just erase this thing, and I guess you have noted this all these points which I have just told you. So let me erase now. and then let me go with the sine, cos and tan ratios for this 45-degree angle. Okay, so in the given triangle, let us suppose that angle C is the 45-degree angle, and not we don't need to suppose it is 45-degree angle, right? Yeah. So now if I ask you to find the value of sine C, which is sine of 45-degree, right? So I hope you know that this sine is given by opposite side. Okay, from AB square. Okay, then fine, let me repeat. Okay, Tejas, don't worry, I'm repeating the things. Yeah, don't worry, I'm repeating, fine. Okay, so you have a theorem in your triangles chapter. So I hope that you have learned your triangles chapter, that suppose you have any random triangle, actually isosceles triangle. So this is your A, B and C. Okay, and if these two sides are same, that is your AB is equals to AC, then these angles are also equal. This is what my isosceles triangle theorem says. Okay, that is, if any two sides are equal of a triangle, then these two angles or the angles opposite to these sides are also equal. Okay, that is, my angle B will be equals to my angle C. This is what my isosceles triangle theorem says. Okay, now using this theorem, suppose that I have a triangle. Okay, and now it is given that these two angles are equal. Okay, what happened? Yeah, suppose that now it is given that I have a triangle PQR, okay, where these two angles are equal. So again, using this theorem, so here in this theorem what I had is that these two sides are equal and then these two angles are equal. Okay, but now here I have that these two angles are equal. So using this theorem I can say that these two sides will also be equal. Okay, so I hope that Tejas, now you are clear with this thing, that now I can say that my PQ will be equals to QR, or sorry, PR. Okay, using the same theorem which I have just told you here. These two things are just a converse of each other. So here, first of all, I had that my sides are equal, then therefore my angles are equal. But here my angles are equal. It is given that my angles are equal, therefore my sides will be equal. Okay, fine, nice, Tejas. So now again let me go with the length of AB and C, AB, BC and AC. So just give me a minute to erase all this thing. Okay, so now again we have assumed that this length of this AB was a centimeter. Okay, and as I have told you, using that theorem of isosceles triangle theorem, so these two angles are given as equal, and this is also 45 degree, this is also 45 degree. Therefore these sides which are opposite to these angles will be congruent, that is your AB will be equals to your BC. Okay, and since AB is given as A, therefore your BC will also be equals to A. Okay, and then again, since this is a right angle triangle, therefore using the Pythagoras theorem, you can say that your AB square plus BC square will be equals to AC square. Okay, and your AB is A, therefore A square, your BC is also A, therefore A square is equals to AC square. Then A square plus A square is 2A square is equals to AC square. Now if I take a root on both the sides, okay, so my LHS will become under root 2A and my RHS will become AC. So I have now the length of AC as under root 2A. Okay, so now I hope that you are able to understand all the things. Okay, yeah, so in this way I have got the length of my hypotenuse as under root 2A. Fine. Now let us calculate the sine, cos and tan ratios for angle C. Okay, yeah. Okay, now if I ask you to find the sine ratio of angle C, okay, so since you also know that your C is a 45 degree, okay, and your sine C will be given as opposite, that is AB, upon hypotenuse, that is AC, right? So your sine C will be given as opposite, that is AB, upon a hypotenuse, that is AC. Okay, so your AB, or the length of AB, is equals to A, and the length of AC is root 2A. Therefore this A will get cancelled out and you will be left with a 1 by root 2. Okay, so your sine C, let me write that your sine C is equals to, or sorry, let me write the 45 degree, that will be more effective. So sine 45 degree is equals to 1 by root 2. Okay, now similarly if I ask you to find the value of cos of 45 degree, okay, so again for this angle C, cos of 45 degree will be adjacent, that is this BC, upon hypotenuse, that is AC. Okay, so your cos 45 will be BC upon AC, and your BC, or the length of BC, is A. So A upon the length of AC, that is equals to yeah, so that is root 2A. Okay, so root 2A, so again this A will get cancelled out and you will be left with a 1 by root 2. Therefore again the cos of 45 degree is given as 1 by root 2. Fine. Then if I ask you to find the tan of 45 degree, so you know that the tan of 45 degree I can also find it by just dividing sine of 45 degree with cos of 45 degree. Okay, so sine of 45 degree is here you can see it's 1 by root 2. Okay, so 1 by root 2, and cos 45 degree, so what is cos 45 degree? It's again 1 by root 2. So 1 by root 2. So since my numerator and denominator are same, that will be equals to 1. Therefore my tan of 45 degree is 1. You can also see that tan of 45 degree is 1. Then sine of 45 degree is 1 by root 2, sorry, and cos of 45 degree is also given as 1 by root 2. Okay, so in this way we have got the values for values of trigonometric ratios for the angles 45 degree. Okay, yeah, so I hope that all of you are able to understand how do I got the values or trigonometric values for this 45 degree angle. Okay, and again you can also check for this 45 degree angle by, sorry, tan of 45 degree angle by this definition of opposite upon opposite upon adjacent, that is the AB is the opposite, okay, and this BC will be adjacent. Okay, so AB by BC, and you know that your length of AB is A. Okay, and also the length of BC is also A, so this A will get cancelled out and you will be left with a 1. Okay, okay, so hi everyone, welcome to the session. Okay, nice. Yeah, so then this was all for the 45 degree angle. So now let us start with the new angle, that is for, okay, and I have summarized all the things here, that is for the 60 degree, for the 30 degree. This is the sine value for 30 degree, the cos value for 30, tan for 30, then the sine 60 degree, cos 60 degree, tan 30, tan 60 degree, and then the sine 45, cos 45, and tan 45. Okay, so this is just a summary of all the values of sine, cos, and tan values of 30, 60, and 45 degrees. Okay. Now let's move for the 0 degree and 90 degree angle. Okay, and for this I guess I will need to use the whiteboard. So let me pull out the whiteboard. Okay, and let me start here. So let us suppose that you have a triangle just like this. Okay, this is any triangle where this is, okay, that's very dark. Okay, fine, not a problem. That's B and this is C. Okay, where this angle B is my right angled. Sorry guys. Yeah, so this my angle B is a right angle. Okay, and now let us suppose what I'm doing is that okay, now if in my triangle, if this is my AC, okay, so what I'm doing is I'm just taking my AC down. Okay, so now if I'm taking my AC down, what will happen is now my triangle will look like such this. Okay, so now if suppose that if earlier this angle was 60 degree, okay, now it is not looking like 60 degree. Okay, the 60 degree, then now it is 30 degree. Okay, then suppose that I am again decreasing, or I am again taking my side AC below. So now, okay, and this is my same, that is A, B and C. Okay, again this is A, B and C. Okay, now this angle is 10 degree suppose. Okay, then I'm again reducing my angle, and suppose that now this is my AC and this is my hypotenuse. Yeah. So this is my A, that is my B and that is my C. Okay, where now this angle is something 1 degree. Okay, now suppose that I'm again reducing my angle. Okay, and suppose now it has become, now this distance is a very small. Okay, and this dotted line is my hypotenuse. Okay, and now this angle is 0.1 degree. Now don't worry, I will let you know why I am doing all this thing, why I'm just reducing, or why I'm reducing this angle and why I'm taking this AC down. Okay, so for now just pay attention what I'm doing. Okay, so now if you will notice in this 5 diagrams, so what is happening is my AB is reducing first of all, right? So my length of AB is reducing and again reducing, so it is going to 0. Right, now if I finally tell you that if I'm further reducing this angle and I got now that this is a very minor angle like 0.00001 degree. So what will happen that my AC or my hypotenuse and this line BC will be overlapped. Okay, they will be on each other. Okay, they are here, both the lines are here. This is my AC and also this is the line, this is the same line BC. Okay, so this AC and BC. Okay, so what's happening is the length of AB is decreasing and again here now it's 0. Okay, and this angle earlier it was 60 degree, then 30, then 10, then 1 degree, then 0.1 degree, and now it's 0.00001, so negligible angle, right? So now you can see that your AB here is approximately equals to 0. Okay, then this angle C is approximately equals to 0 degree, right? So now let us suppose that, and yeah, one more thing that you can see that your now AC or the length of the hypotenuse and this length of BC are seeming equal. Okay, that is the length of AC is now being equal to your length of BC. Okay, I hope that everyone is able to understand, but still if there is any problem, even a single problem, then please write in the chat box. Okay, I will be happy to answer your questions. Yeah, but please don't be confused. Okay. Yeah, so what I'm just doing is, first of all, I'm just reducing this length of AB. Okay, and I'm also reducing this angle. Okay, so now therefore in this triangle, okay, my angle C is very negligible. Fine, then my AC is approximately equals to BC now, right? My AC is approximately equals to BC and this AB length is approximately equals to 0. Okay, so now suppose that if I ask you to find the sine of angle C. Okay, and you also know that your angle C is 0 degree. Okay, so your sine C will be opposite, so for the opposite side of this C is AB, right? So your sine C will be AB upon the hypotenuse, which is AC. Okay, and from here this equation, you know that your AB is tending to 0, that's why your AB is equals to 0 by AC, and that is equals to 0. Okay, so okay, here I should write the sine 0. Okay, that's why I will say that my sine of 0 degree is equals to 0. Okay, so therefore I have got my value of sine ratio of 0 degree will be equals to 0. Similarly, if I ask you to find out the cos ratio, okay, let me use a different color for cos ratio. So cos of angle C. Okay, so now you know what is the cos, so it will be adjacent. So since this was your C, right, so your cos will be adjacent upon hypotenuse. Okay, so what is your adjacent? It's BC upon the hypotenuse, which is AC. Okay, but from this equation you know that your AC is equals to BC. So in the place of BC I can write AC, so that is equals to AC upon AC. So this will get cancelled out and you will be left with a 1. Therefore finally you have that your cos of 0 degree is equals to 1. Right, and now similarly if I ask you to find the value of tan of C, okay, so your tan of C will be given by opposite upon adjacent. Okay, that is AC by, sorry, not AC, sorry for this. Yeah, so let me use a different color now. So AC by what is, it's BC, right? Yeah, okay, again I have made a mistake, that should be AB, and okay, sorry for this again. Yeah, so my tan C will be AB upon BC, right? And again you know that your AB is equals to 0, so 0 upon BC, that means your tan C is equals to 0. Okay, so your tan of 0 degree is equals to 0. So in this way you have got the values of sine of 0 degree, then cos of 0 degree, okay, and then the tan of 0 degree. Okay, let me see if you have any questions. Okay, no questions, fine. Okay, so now this was all for the 0 degree angle. Now what if I ask you about the 90 degree angle? Okay, now let me show you from this angles itself, and okay, let me cut all of this thing and let me paste all this thing on a new slide. Yeah, so this is copied. Okay, and let me paste all of them. So okay, how to, okay, shit, okay, I don't know how to, okay, just forget all this thing, and let me add a new board. Okay, where to add the new board? Okay, fine, just leave it. Let me tell you from here itself. Okay, so and let me use a different color, this one. Yeah, okay, so again in this triangle ABC, now when I was decreasing this angle, okay, when I was decreasing this angle, my this angle was increasing. Okay, what's okay? So when I was increasing this angle, I was decreasing this angle, my this angle was increasing, right? So when this was 60 degree, this was equals to 30 degree. Okay, then now when this was 30 degree, this was equals to, okay, yeah, so this was equals to my 60 degree, right? Now when this was 10 degree, this was equals to my 80 degree, man. Yeah, this was equals to my 80 degree. Okay, now when this was 1 degree, this angle was equals to my 89 degree. Okay, I hope you are able to understand. Okay, and when this was my 0.1 degree, okay, then this angle A was my 89.9 degree, right? And now when this angle is 0.00001 degree, at that time my this angle A, or the angle A here, so this angle A is now 89.99999 degree. Okay, that means now this angle A is tending to the 90 degree. Okay, so if I make a, so this my angle A is tending to the 90 degree right now. Fine. So now let me erase these things here which I don't want now. Yeah. Okay. So now I know that my angle A is tending to 90 degree. Right. And okay, I have the information before that my AB is equals to 0. Okay. And my AC is equals to BC. Fine. So again, let me again have a look over the chat if you have any questions. So okay, no questions. Fine. Yeah, so then again, now if I ask you to find the value of sine of 90 degree, okay, or the sine of angle A, okay, let me write the A itself so that you won't get any confusion. Yeah, so sine of angle A is equals to sine of 90 degree, right? So sine of angle A will be given by opposite, that is BC upon hypotenuse. So BC upon hypotenuse, which is AC. Okay, so you again know that your BC and AC are same. Okay, so I can write my BC as AC itself. So my AC upon AC will be now equals to 1, and therefore my sine of angle A will be equals to 1. Okay, similarly for the cos of angle A, that is cos of 90 degree will be equals to, so cos of angle A will be given by adjacent upon hypotenuse, right? So adjacent is AB. Okay, let me write a bit downwards. Yeah, so my cos of A, that is cos of 90 degree, is given by AB upon AC, right? But you know that your AB is equals to 0. Okay, therefore your AB is equals to 0. The 0 upon AC will be equals to 0. Okay, then if I ask you to find out the tan value of angle A, that means the tan value of 90 degree. So the tan of this angle A is given by the opposite, that is BC, upon adjacent, that is AB. Okay, so tan A will be given by BC upon AB. Okay, and you know that your BC is okay, BC have any values, and AB is equals to 0, so your BC upon 0, right? Now here you should know that if you have any real number upon 0, then that is always not defined. Okay, you should know this thing, that any number upon 0 is always not defined. That's why your BC upon 0 is not defined. Okay, and you should know this thing. Okay, so okay, let me when I was in class 8, I mean when I was just past the class 8 and just have taken admission in class 9. So there was my uncle, and once upon a time he asked me, okay, he was just lying on his bed, and he just asked me first of all that what is 0 by 1, what is 0 by 1. So I told him that it's 0, right, that is 0. Okay, then he asked me what is 1 by 0. So what I replied is again 0. I said that 1 by 0 is 0. So at that time he told me that no son, this 1 by 0 is not equals to 0, that is not defined. Okay, and what he asked me is to do this calculation on the calculator. Okay, so I did there. I first of all wrote, then divided it by 0. Okay, and it is written 0, but on the corner of the calculator it was written e. Okay, if you can use, or you can check that if you will divide 1 by 0 on the calculator, so the answer will show as 0, but there will be an e on the corner of the calculator. Okay, and this shows that your answer is infinity. That means not infinity, actually not defined. Okay, you can try yourself on the calculator, and yeah, you can check. Okay, and what I want to tell you that is 1 by 0 is not defined. Okay, that is not equals to 0. Okay, this is the mistake which I have did when I was in, okay, sorry for the background noise. Yeah, so this is the mistake which I have did when I was in class 9th. Okay, but you shouldn't do it, and you should always remember that 1 by 0 is not defined. So that's why your BC by 0 is also not defined, and therefore your tan of 90 degree is not defined. Okay, let me erase this thing. Yeah, so I have erased it. Yeah, and you should note that your tan of A is not defined. Okay, and also we have found out the sine and cos and tan of 0 degree. So let me remind you, so that sine of 0 degree was equals to 0, then cos of 0 degree was 1. Okay, and tan of 0 degree was again 0. Okay, and you can also verify with from the formula of tan theta. Okay, that is tan theta is sin theta upon cos theta, right? Sin theta upon cos theta. So for the 0 degree, your tan of 0 degree will be equals to sine upon 0, sine of 0 degree upon cos of 0 degree, right? So your sine of 0 degree is 0. Okay, so it's 0 upon cos of 0 degree is 1, and that is equals to 0, right? And therefore your tan of 0 degree is equals to 0, which you can see here. Okay, similarly you can also check for 90 degree. So yeah, so for the tan of 90 degree, which is equals to sine of 90 degree upon cos of 90 degree, right? So your sine of 90 degree is 1, right? So that is equals to 1, and your cos of 90 degree, okay, so teach Nawaz. Okay, actually I should have explained in Hindi or Marathi also, but see, we have a strict instruction that we cannot speak in Hindi or Marathi. Okay, so sorry for this, and yeah, that's all what I can say. Okay, so yeah, again sorry. Okay, and we know that my cos 90 degree, so my cos 90 degree is 0. And also one more thing, that the session is now at the end, so now there is no point in explaining the things in Hindi or Marathi. Okay, yeah, so sorry again. Yeah, and again your tan 90 degree you found out is 1 by 0, and again that is not defined. Okay, so that's why you have found out that your tan 90 degree is not defined. So in this way, we have found out the sine, cos and tan ratios for 0 degree as well as for the 90 degree. Okay, and let us verify whether these answers are correct or not. So sine 0 is 0, then cos 0 is 1, tan 0 is 0, right? So let us verify. Okay, let me show you the table. So yeah, so sine 0 is 0, then cos 0 is 1 and tan 0 is 0. Fine. Then similarly for the 90 degree also, let us check. So my sine 90 degree is 1, then cos 90 degree is 0, okay, and then tan 90 degree is not defined. Okay, so your sine of 90 degree is 1, then cos of 90 degree is 0, okay, and then tan of 90 degree is undefined or not defined. Okay, so in this way we have found out the values or the trigonometric values of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree angles. Okay, and that's all I have for today for you guys. Okay, so this was for 30 degree and 90 degree, and yeah, again you can have a look at this table for a fresh look. Okay, and all the values for all the value or the trigonometric values of sine, cos and tan at 0, 30, 45, 60, 90 degree angles. Okay, and one more thing, that you should always remember these values, or you should even remember the table itself. Okay, and in the class 10th you will have a bit larger table, and in the class 11th and 12th again you will have a more larger table. So there you will be for, you will have an angles up to 180 degree. Okay, so then you will need to also remember the angles for 120 degree, then 135 degree, then 100 and yeah, all the up to 180 degree. Okay, so make a habit of remembering this table. Okay, and you can remember this table very quickly. So you just need to know the first line only. Okay, once you know the first line, you can see that your second line is just a reverse of your first line. Okay, you can see that this is 1, so this is also 1, then this is root 3 by 2, so therefore this is also a root 3 by 2, then this is 1 by root 2, this is 1 by root 2, then this is half, so this is half, and this is 0, then this is also 0. Okay, so what we just did is, we are going to the right hand side on the sine, and we are coming on the left hand side on the cos. Right, so here we are starting at 0, again here we are starting at 0, but from the last. Okay, so in this way you can remember this table, and you know that your tan is sine upon cos, right? So you can just find out, if you know the sine and cos values, then you can just find out the values for tan. Okay, so for 0 degree your tan will be 0 upon 1, that is 0. Then for 30 degree your tan will be half upon root 3 by 2, so this 2 will get cancelled out and you will be left with a 1 by root 3. Okay, similarly for root 5 your sine and cos are same, therefore this will get cancelled out and you will be left with a 1. Then for 60 degree this 2 will get cancelled out and you will be left with the root 3. Okay, and then for 90 degree your tan will be 1 upon 0. Now you know that this is not defined, so therefore your tan of 90 degree is not defined or undefined. Okay, yeah, so in this way you can also remember this entire table. Fine. Okay, then if any one of you is having any question, you can write in the live chat. Otherwise we will end the session here itself. Okay, because that's all which I have for today, and yeah, that's all. Okay, and again thank you very much for attending my session, and yeah, then again we will have our next session on 23rd of January, that is the next or this Saturday. Okay, at the 6 p.m. itself. So we will again meet on Saturday at 6 p.m. with a new topic of surface area and volume of solids. Okay, So we will learn some of the tips and tricks to remember the formulas for the surface area and volume of the solids. Okay. Yeah, so then I guess I should end the session here itself, and then let us meet on Saturday. Till then, take care of yourself and take care of your families. And yeah, then bye bye.
Ariandu.